Sorry, I'm really sorry. Thank you for
It's
joining on
okay.
short
It's okay.
notice. So what's up?
Okay. Well, can I share
Yeah,
the
yeah, sorry, I wanted to give you
presentation? Okay.
permission. First of all, before we start, congratulations on the work done. This is really
Mm-hmm.
good. So today's meeting is to determine whether we have all the data necessary to write the papers,
Yeah.
right?
Okay.
And my plan is, I want to tell you right off the bat, my plan is for you both to be first co-authors on the germanium telluride high entropy thermoelectrics because you guys deserve it.
Mm-hmm.
So that's that.
Okay.
I think you think since Jayanta is already doing his PhD, he will be first
Mm-hmm.
and then you will be second, but both of you will be equally contributing authors.
Okay.
Um, if any of you has a problem with that, please tell me and we
Mm-hmm.
can talk about it. No problem. I'm very open with this stuff. So yeah.
No, I think like yeah, you can like prefer Yuting first because he read more than like me actually. This so
You think you'll be first then. Thank you, Jayanta, for your
Thank you.
honesty. I think that's a very great quality for a scientist. Like working hard and being smart is only the entry. You have to be your reputation is super important, and being honest goes a long way. So Jayanta, congratulations. I'm very
Yeah.
proud of
Thank
you.
you.
You think congratulations, you too. Let's do this.
Okay. Um. Here. See. Okay. So this one is the one that we present
Yeah,
last week,
yeah.
the 2 weeks before. So this
Mm-hmm.
is the DJI sample without the SPS.
Mm-hmm.
So I have done the XRD for the SPS sample as well. You can see from here.
Mm-hmm.
And I compared this SPS sample and DGS one.
Yeah,
So this one is this one.
yeah,
Yeah. So this is six sample is the one we do like last week, and we
yeah.
can see the trend here. So just as
Mm-hmm. Mm-hmm.
before the after SPS, the peak like the phase
Yeah,
transition temperature will shift further
yeah,
towards the room temperature,
yeah.
right?
Yep.
So
Any
the
problems
peak will
with the
merge together.
yes, you think you're correct. And Jayanta,
Yeah.
any problems with the SPS? Is everything working well? Do you
yeah,
have any problems
yeah,
with that?
no, 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 working well.
Yeah. Okay.
Yeah.
Please, you think carry on.
Yeah, so it's the same as
Mhm.
before.
Yeah.
And here is the CTA. So the light pink one, the button, uh, this one is
Yeah.
sorry, I
Yeah.
put my pen here. So this one is the one
Mm-hmm.
that we done
Okay.
new newly done.
Yeah.
So this three is the heavy dope sample.
Yeah.
This three, and this one is no SPS.
Mm-hmm.
And I compared with
Yeah.
the
Yeah.
sorry, compared with the one we have done SPS.
Yeah.
So this is the
Yeah.
heavy dope fourth heavy dope
Okay.
sample here.
Okay.
Yeah.
Mm-hmm.
So there are 5 recipes, but I only have done 4 because what I only can only do four jars one time,
Mm-hmm.
and the DJS instrument is currently down, so I cannot do the last one.
Yeah.
Yeah. And for DJS, because the one doped with aluminum will break,
Yeah.
I cannot do so
Yeah.
can only do SPS. So
Yeah.
there's 4.
Mm-hmm.
Um, and this is the one we doped with aluminum
Yeah.
and compared with the
Mm-hmm.
CDT dopant.
Okay.
Yeah. And this is the thermal transport,
Mm-hmm.
overall thermal transport. I asked Pavan about the Lorentz number.
Yeah.
I asked 2 weeks before, and he replied me like he said he will give me the Python code.
Yeah.
So I said yes, but
Okay.
he didn't like reply me.
Is it Pawan?
Yeah,
Okay, let me text him now.
yeah, okay.
He's leading a few projects now, so
Yeah, I guess
he has a
he's very
lot going
busy.
on. Yeah, yeah, yeah.
Yeah.
Pawan is he suffers from success, so like it's a good problem to have. Let me send him a text. Hi, Pawan. could you please send using the Python code for L? Thanks a lot.
Thank you.
No problem. Yeah. Okay, so let's see. So Ethereum is really bad, huh?
Ethereum is very bad.
Yeah.
So here, like
Yeah.
here, I put it.
Yeah, I
This
see.
is the new one.
Okay. Okay. Do you have SCM images by any chance, Yutin?
No, not for now. I can do it this week.
Okay, take some SCM EDS images to see
Okay.
basically like how it looks like at the micro scale level.
Okay.
My suspicion is that Ethereum is gonna be very phase segregated, most likely.
Yeah.
It's also crazy that the thermal conductivity is so flat.
Yeah.
That's interesting. That's very interesting. Okay. Okay, let's go to the overall transport then. And let's talk about, so let's talk about how we are going to distribute the papers, right? I think this is going to be two papers. We're going to take the AI compositions and send them to Andre because he needs to do some stuff. So you think at your convenience, in an Excel document, have basically the data they used to plot this, right? No raw data from the CTA. That is useless. That nobody cares about that. You know, like that's for us and that's it. We need temperature as a column and then sigma, S, power factor, thermal conductivity, all of that coefficients as a function of temperature in a single Excel, right? Which is basically the data that you use to make these graphs, correct?
Okay.
So take your origin or whatever you use to make these graphs, copy that, put it in an Excel document, and send it to me, and I'll make it, and I'll send it to Andre. So only for the AI compositions, right? That is the aluminum, the. Do we have more aluminum, yttrium, and the others, or we only have those three?
Only have these three.
Only have these three. Okay, fair enough.
Yeah.
Three is three times more than one. Okay, perfect. So get those and send it to me, please. I'll get it to Andre.
Okay.
And he can overlap with the AI predictions, and we can write that paper because that's AI and thermoelectrics.
Okay.
And then for our GT paper, the good news is that we have done a lot of samples. The bad news is that we don't even have a ZT of 2.
Yeah.
So and push comes to the worst part of it is that the 5% BI is the best, which is very surprising. So we should at some point understand why that is. But we're gonna write that essentially, right? Like we're just gonna write the paper showing how. Why do you guys think the 5% is the best?
Maybe because let me see that here. Maybe because the solubility limit.
Yeah, but for instance, like antimony and silver are very good dopants for germanium telluride.
Yeah, I think in like some papers they say like 5% or 6% bismuth with 10% antimony is really good.
Yeah.
Like it can reach like 1.8 or something.
Yeah, but so
we
why
can only reach 1.4 or 1.5? So I don't know.
Yeah, why do you guys think that is? Interesting. We need to find an explanation for that because the reviewers will ask, right?
Yeah.
Okay. Fair enough.
Find the SPS, this one, no, not this one.
Pawan just sent you the code, by the way.
Oh, thank you.
Do you know how to use it?
Not sure, but I can figure it out.
Okay.
Yeah, I can try to learn it.
Yeah, give it a shot, and if you don't, we can have a Zoom meeting, and I can show you how to run it because I'm familiar with that. I've written similar codes as well, so I can help. Jayanta, you are most welcome to join as well.
Yes.
Obviously, I mean,
Yes.
I don't have to say it explicitly, but I think it's useful for you as well to learn how to use it. So I would encourage you to. I know you have a lot going on, but I would encourage you to make time for it.
Yes, definitely. So let me know when you are just teach us.
Yeah, you think take a look, and if you don't know how to do it, text me in the group, and then
Okay, okay, sure.
so October is a bad month for me because I have a lot of deadlines for a lot of things.
Okay, sure.
So that's why I've been lagging a lot in the paper department and for everything, which is the reason I get scolded at every meeting that I have. But hopefully in like 2 weeks or so, I should be more free. You think? I'm sorry, it's 2 weeks,
Okay,
and I know it's
okay,
a
no,
long time, but like
it's okay. I can figure out
I
first. I
I
try
have
to.
I have to meet a deadline on the 14th. I have another on the 24th, and I have another on the 27th.
Yeah,
And also Gerd is coming back because he's on sabbatical with his startup, and he's coming back to Berkeley at the end of the month. So I'm supposed to present him some stuff, and he is not the sort of man that takes kindly to failure. So I have to succeed.
yeah, sounds
Uh,
tough.
yeah. So I'm sorry about it. Okay.
It's okay, it's okay.
Right. So Jayanta, how are you in writing your papers? Do you and Yuting have bandwidth to start writing the GT paper?
Okay, actually, I am like writing my paper, so it will be for me difficult to.
Fine,
I'm currently
fine.
like doing my dissertation.
You're doing
So
your
maybe,
dissertation.
yeah,
Okay.
yeah. So maybe like I can I can like put a part of it for
Okay.
the
So what? How
paper.
about you? You think when is your dissertation due? You think?
Next year, January.
Oh, so why are you writing it already?
I just writing the like what is it called? The literature review.
Oh, but you have a
Yeah.
lot of time. I thought your dissertation was due like next month.
Yeah. It's basically
Okay, okay,
like
okay, okay, okay.
1.5 year.
Okay, okay. Oh
Yeah,
man,
yeah.
like, oh, you have a lot of time. You have a lot of time.
Yeah,
Okay.
but if I want to like graduate soon, I need to
Yeah. Okay.
like hand in the paper soon. Yeah.
Okay, that's fair enough. Then, um, I have 3 papers that I owe.
Oh my God.
Um,
This year.
in Singapore, not here. Like here is a different
Oh,
story. Here there is like a few more as well. Um, so I will try to write something, but it's not gonna happen anytime soon. So you think it would be great if you could like help me out prepare the figures
sure,
at
sure.
least.
Yeah,
So
even I can also help to prepare the figures.
no, Jayanta, you focus on your paper because it's more important. So Yuting and I will take the
Okay.
lead on this, and later on, when you are done writing your paper and you are waiting for comments or whatever, which by the way, if you want me to read through and give you comments, I have pretty much read and written every paper from Kedar's group over the last 3 years. So most likely he will tell you to send it to someone before he reads it. So
No, actually, yeah,
I can
actually for
volunteer.
my paper, so it's like I'm writing, and for the copper germanium, so Kedar already go through the paper.
He did?
Yes.
Okay, wonderful. I guess Partha told him to do it.
No, no,
Great.
when I gave him the paper, so he just sent me back in 2 days. Very fast.
Yeah, I guess Partha told him like he wanted to put this out as soon as possible. So fair enough. That's good. That's a good thing. Um, Great then. Okay, so Yuting and I will take the lead, Jayanta. You focus
Okay.
on your paper. That's good for you. So, yeah, we will take care of this. Okay.
Okay.
Yuting, figure wise, the first figure should be a. Let me see. Okay, the first figure should be basically a comparison between the traditional synthesis and our synthesis. And
Yeah.
we should be calculating a throughput method. So how much time does it take with traditional synthesis? So take any germanium telluride paper, look at how much time does it take, and then calculate the ratio between the time that it takes for us The second figure should be characterization, so all the XRD, SEM EDS, and for the best sample, we will do some TEM. So I'll speak to Haiwen or Chengguang, and they will do TEM.
Okay.
And the third figure will be thermoelectric performance, essentially. It might be good to get some EBSD of the best performing samples, just to see how it looks like. So do you still have the samples, you think?
You mean the previous one or the some new like the one did not appear on the
Yeah,
graph?
I imagine that you have the samples, right?
Yeah, I have most of the sample, I think.
Perfect. So then we will pass 1 or 2 or 3 to our IMRI collaborator,
Okay.
and she will do some EBSD on them.
Okay.
And so we can have that as well.
Which sample, like most everyone or
No. We will give
choose
them
specific one?
like the baseline sample, 5%
Okay.
bismuth because it's the best.
Yeah.
And then maybe can we go to the transport?
Transport to okay. This one.
Okay. Yeah. Okay, I need to think about it because I have an idea for something, but I need to see the SEM. So I think it would be good for you think to compile an let me show you. Hold up a minute.
Okay. Let's stop the sharing, right?
Yeah. Stop the sharing.
Okay.
It would be good to have something like this. See? Something like this, but
Oh,
for our samples, just to show the evolution with the dopants and so on, and see like, and that could be like figure 2. You know, the TM will be figure 3, BSD will be figure 3, and the
okay.
transport will be figure 4, right?
Okay.
So we can have a big SEM EDS matrix showing how the dopants behave, you know.
Yeah.
And ideally, we should have this for DJS samples and after SPS to see the change.
So DJS and the
Yeah.
SPS sample for.
Yeah. But
Great.
this it's a lot of data, but it shouldn't take a lot of time because it's SCMEDS, you can get a lot of samples done very quickly.
Yeah.
You know, so
So which one we can like focus on the SEM?
I mean we need them all, to be honest.
All of them. Okay.
Yeah, we need them all. Start from any and get them done. And then because some of them, so the AI compounds, we need them for the AI paper that Andre is writing. So those
Yeah.
have to be there anyway.
Yeah.
And the others, we need them because I think they will help us write a more coherent story. So I was thinking that the paper could be about dopant, like fast dopant incorporation and how does it work,
Okay.
and how that links into the performance. Because you know, like the fact that ours should be much higher and it's not, it just means that like the SPS does something. So we can basically say that doing only DJS is much better than doing SPS because it saves times, but it
Yeah.
also because the performance is better.
Yeah, that's right.
in high entropy thermoelectrics, which is a very hot topic right now. So that could be quite a nice paper to write, honestly.
Yeah.
Because since our performance is not good, we need to find other selling points. Like if our performance was good, that's it.
Yeah.
End of the story.
But we cannot like compare the performance of the DGS and SPS because of
We can compare the electronic
sample.
transport.
Electronic. Oh, I see. So
The thermal, no, sadly, because and in fact that's the problem. We could
yeah,
never
that's
get a
the
decent
problem.
pellet to do thermal transport, right?
Yeah.
So that's why we had to do this. But we can still compare the electronic transport, and the electronics transport decides doping.
Yeah.
So in a way, we are comparing. Our central hypothesis is that DJS leads to a much more closer electronic transport optimization than doing SPS.
Yeah.
So for high entropy thermoelectrics, it's better to do DJS because it's faster, but also it gets you closer to the optimal point anyway. And
Yeah.
in fact, we can use the code that Pawan sent to visualize that, because we can have power factor as a function of chemical potential and construct a graph that looks like this. I know all of this because I did all this analysis for the AST paper. So, this is something I've been doing for a while now. So, we can have these graphs and these graphs,
Oh.
right? And we can have DJS and SPS and show how that works. And that would be a really nice paper, honestly, because it excuse me, guys, quantitatively, in a quantitative fashion shows that DJS is better.
Yeah. So this graph is like compared by the Python code, right?
Yeah. So I mean,
those graphs.
the code doesn't give you that, but from that, I constructed those graphs.
Okay.
So I can show you guys how to do it. I mean, Jayanta, I know he knows how to do it anyway, but like, you think it would be good for you to learn?
Yeah, sure.
Okay. Yeah. Okay. Perfect. Great work, guys. This was
Yeah.
amazing. Congratulations on the end of the journey. You think, please send me the AI data, compound data as soon as possible, so I can send it to Andre.
Okay.
Now that he's left the group, he doesn't work every day on this. So,
Yeah.
and then like him and Thor will write one of the papers, and then.
So he was still helping us with these papers, right?
Yeah, he's still involved. He still works on the catalysis stuff too.
Okay. That's good.
Because the results are too good for him to not be involved. Like like in a way, I'm sad I came to Berkeley because that's my project. Like I actually developed it. I came up with it and I figured it out. And now when things are going well, I had to leave.
Oh, that's sad.
It's okay, man. That's fine. Anyway, great to seeing you guys. Enjoy the rest of your day, and we will. You think? Please have a stab at the figures.
Yeah, sure.
Okay.
I will do it.
Text me if you have questions. Jayanta, focus on your papers. And whenever you get time, you can get involved if you want. And if you don't, then don't. Up to you.
Oh, I can help. Yeah.
Wonderful. Thank you, Jayanta. And writing the paper, we will see if we are missing some data. So at least we can figure it out along the way.
Okay. We can start plotting the
But in
graph.
principle, these pieces of work are done. Okay?
Okay.
Great, guys. Thank you so much. Enjoy the rest of your day.
Thank you.
Wonderful to see you. Bye-bye.
Thank you. Bye-bye.